I'm just going to give you a quick overview of how to find the area of a regular polygon. Remember, regular polygons are polygons that have all congruent sides and all congruent angles. And so I've got an example that has a hexagon on here, and I've made it so that all of the sides are 10, we'll say 10 centimeters. And we're going to try to find the area. And so the best way that I've found is that we split it up into triangles, almost like a pizza. So then we're splitting this one, so it says 6 sides, we'd split it up into 6 triangles, because then we can just do 1/2 base times height, right? We would just need a base and a height. And if you could do 1/2 base times height and then just take 6 of those, then you'd have the total area. That's the basic idea. Instead of calling it the height, which wouldn't really make sense, because really it's only going from the center down. If you look at this, it's going from the center down. They don't call it the height, because probably the height would want to be from the top to the bottom. So instead of calling it height, they call it apothem. Apothem. It's just the perpendicular distance from the center to the edge, to the side of the polygon. And you can do some fancy SOHCAHTOA now, since we have like some right triangle stuff going on. We know how to find angles in our polygons, but I'm going to save that for later, and I'll just tell you I did a calculation, and the length of this apothem is 8.7 centimeters. And so basically you're just going to do 1/2 base times height and 1/2 base times height, but all of these are congruent. So when we do 1/2 base times height, we're basically using every single side as a base, right? So just a shortcut for saying 1/2 base times height would be to do 1/2 still, but instead of just using one base, why not just use them all at the same time? And then take it times the height. So that's where this formula comes from. It's from the equation for a triangle area. It's 1/2, and then P stands for the perimeter, which is just the same thing as taking all of the bases at the same time. So 1/2, they put it out of order, 1/2 of the bases of the triangle times the height of each triangle, which we call the apothem. So we've got the apothem that goes straight to the edge. Just so you know, if we were to, instead of going to the sort of the midpoint, if we went to the vertex of the polygon instead, that's what they call the radius. And the reason it's the radius is because, well, I drew this circle around here so you could see why. Because it would be the radius of the circle that circumscribes about your polygon. Here are some more examples, and it turns out as long as you have a regular polygon, you can split it into triangles. And these triangles are congruent. I think my resolution is off on my camera a little bit, so they might not look regular, but they look regular to me. So if it has 5 sides, we'll have 5 triangles. Square, I don't really know why you'd use this on a square, you probably wouldn't, but you could have 4 congruent triangles. An octagon, 8. It'd be really dumb to do it on a triangle, but you could. On a regular triangle, an equilateral triangle, you would have 3 congruent triangles. So let's just do a couple of examples. Well, maybe we should do this hexagon. So all we would have to do to find the area of that hexagon is to take 1/2 times the apothem times the perimeter. And perimeter is just adding all those sides together. So we'd add 6 10s in this example. The total perimeter would be 60. And then we could just calculate that. So I'm going to do, I use 0.5 times 8.7 times 60. 261. And if those lengths were measured in centimeters, square centimeters would be our unit. Just a couple more examples I made up. And these are pretty simple because we know the apothem. This one right here, I drew the apothem sideways, but really it's a regular shape, so whether it goes straight down, that represents the height, I guess, of this triangle. But all 5 of the triangles on this pentagon are going to be congruent, so it's going to work the same way. So my apothem is at 6.5. Each side, since it's a regular pentagon, each of these is 9.3 inches. The area of a regular polygon, 1/2 apothem perimeter. So perimeter would be 9.3 plus 9.3 plus 9.3 plus 9.3 plus 9.3, or 9.35 times. So 46.5 is my perimeter. And that's all I need. So I'm going to do 0.5 times apothem times perimeter, 151.125. And this one would be in square inches. This octagon, not a whole lot different. I thought I'd give you the height this time instead. I gave you the entire height of this stop sign. Okay, it's in meters. It's an enormous stop sign. But if you think about it, from that 19 height, we really do know the apothem, right? The apothem is just going to be sort of, it's almost like we know the diameter and we're going to find half of it. Technically, the diameter would go from vertex to vertex. So if you know the height, you just want to use half of that. So what would that be? 9.5 meters would be the height of the apothem. So area would be 1/2 apothem times perimeter. And now sometimes I've even seen books that spell this out for you. If you're going to add 6.9, 6.9, 6.9, in this case 8 times, I've actually seen books that break down that P for you just in case you can't add together all the sides, which I think is dumb. But anyway, instead of saying P, they would say S times N. That just means the length of this side times the number of sides. I think you can figure that out on your own. So the perimeter of this octagon is 55.2. So the total area (262.2). And that would be in square meters. Like I said, these can get more complicated because if I didn't give you the apothem, you might have to do some right triangles, SOHCAHTOAs, or a squared plus b squared equals c squared, if they gave you the radius and you needed the apothem or something. But we're just going to work on some basic ones for now. And so all you need is that apothem and perimeter, and you can find the area of any regular polygon.